Hey everyone, it's Iana Kone. Hey, I thought I'd give you part one to the video lecture on a word problem I made that you'll like, exploring rates and variables. And you'll like it because the rate involves how much money you'll make once you graduate. And it's a lot. Look at that, 69 grand your first year. Oops. So I'll let you read that. Hopefully you've got the handouts for this printed out or at your side. So you'll make this on average, and I got it from salary.com a couple years ago, so it's probably more now. And look at that. You typically get a $4,000 raise every single year. Now here I asked you to predict how much you would be making in your second year, then fifth and seventh. And be careful because I skip years here. And I did it on purpose because you'll be asked to do the same thing in some of your handouts, I believe. So if you've got the handout, check out this table here I've got for you. This is a great way to solve it. Your year's experience, your 0 year when you first get hired is 69225. And that's considered your 0 year until the end of the year when you get your first raise at year 1. Then that's 69225 plus 4,000, and then you keep on adding 4,000 every single time. This is another word problem that comes later in the handout, but I asked you to graph it here. Well, if you were in class, I'd ask you to graph it, and I gave you the x and the y-axis because you'll never have to make this for the quizzes. So look, years experience and salary right there. And I'll take you through graphing it. What this problem does is it helps you make a connection between the word problem and the table and the graph, and then all the things on the graph like slope and y-intercept. So hopefully you'll be able, since you see a connection between all these three things, it makes the problems easier when they just start asking about slope, because you can always relate the problem to a word problem. And the easiest one to relate it to is this one on the amount of money you'll be making, because that's important to you. So here's the second page. And oops, here's the second page. I asked you to write an equation. Now, I'm going to show you that in a minute, although it's 69225 plus 4,000 times how many numbers you've been working there. Let's take a look at that equation. That's the second part to the word problem. This is on page 3. Here's the equation. So 69225 is your starting salary, and 4,000 is the amount of raise you'll get every year. And because you get it every year, it's a variable, and that the variables change. And what that means is that letter X stands for the number of years you've been working there. So maybe you're already making a connection between the word problem and these numbers in the equation. Typically, the problems you'll see on the quizzes will just be an equation. There's no word problem with it. But because you're starting with a word problem, this number makes sense to you. It's the amount of money you'll make. And we'll see what that number looks like on the graph, and then that on the graph. So let's look down here. I've got the table filled in. Let's look what it looks like. And hopefully you've printed this out or you have it. So think about the word problem is you start at 69225, 69 grand, and then you get a $4,000 raise every single year. Your variable is your numbers of years worked, because that's the thing that changes as you work longer. And here's the table. When you get hired first day, you get that amount of money. When a year comes up, when you've been there a year, they give you a $4,000 raise. Boom, 73,000 at the end of your first year. That becomes your second year, plus $4,000. Look at that. At the end of your, at the beginning of your third year, you're up to 81 grand. That's the average salary in nursing. So just 3 years out of college, you're making $81,000. That's really nice. All that extra work. 4 years, 85. Look at that. By 7 years, you're almost at $100,000. Now, since we're on it, this is another word problem. And if you go to work in Nevada in a high needs area, whatever that means, it could be a city where they don't have a lot of nurses, or an area of nursing they don't have a lot of people. You get a signing bonus, and you're starting out at $76,000. And well, here's the word problem right here. So this is the second word problem, Y2. You're starting out at 76 through 225, and you're getting a $5,500 a year raise, even more. Of course, this is a high needs area, or a city where they don't have a lot of nurses. But look, if you choose to go this route, by 7 years, you're making $114,000. Well worth all the studying and sacrifices you're doing. In class, I would have taken you through how to graph this, but I've got lots of help on my web page. So if you think about this number here, this dot represents 69. See, it's 70,000. It represents 69,225. It's just below the 70K mark, and it's at year 0. This number here is called the y-intercept, and look at it in the equation. Here, see that equation? See that number right there? That's the number. That's the amount of money you're starting with. That's called the y-intercept, and it's the number here that doesn't have a letter with it. It doesn't have a variable with it. It's the number you start with, the salary you start with, and this 4,000. If you think about it, it's the increase every year. Well, let's look at the graph here. We started at 69,000. We go up 4,000. You go up another 4,000, you go up another 4,000, you go up, and you just keep going up 4,000. That's called the slope. It's the amount you increase every single year. So let's look back at the equation. Here is the y-intercept. That's the amount of money you started with. And here is the slope. That's the amount you go up by every single year. You raise every single year. The slope is the amount of increase every single year. So you can see that on the graph. Now you might have noticed I did a little triangle right here. I went up and over. This is called up and over. This is called the slope triangle, going from one point up and over to the next point. And it's this up that we're concerned about here. It's up $4,000 every single time. You go up $4,000, you go over a year. You go up $4,000, you go over a year, and so on and so forth. So let's look at we might be to the end of it already. Oh, this is what it looks like if I did it on a computer. Same graph. This was the average salary, and this was the salary if you go to work in a high needs area. Oh, look, and it's labeled up there. This problem I made up, and I asked in class, what happened that in like year 6.5, where you got a sharp increase in salary? What could have happened right there? Think about it for a sec. Something happened. Here you're getting $4,000 raises. And then all of a sudden you're getting, might be a $15,000 raise. What could have happened there? You could have got a promotion. Maybe you're a head nurse or something like that. And now you're making a lot more. So that's an interpretation of a graph. And let's see. Here is really what I wanted to share. It's this is called multiple representations of a graph. Whenever you think of a graph, which you'll have a lot of on your quizzes. You can also think about that graph in a table, like I've shown you. You can also think of that table in an application or a word problem, like the amount of money you're getting. And that amount of money, that word problem, can actually help you make sense of the table. And that word problem can help you make sense of the graph. And then again, it can help you make sense of an equation. Now, in your quizzes, you're not going to be given a word problem. You're going to be given an equation or a graph or a table. And in previous years, just because I share this, how these three things are tied to a word problem, students make more sense about it because they think about this 69225 and they think about its equation, and it helps them with new problems. And that's the idea here. And this is a real old idea in algebra, to link these four things so that students can understand it a little bit more. So here is the equation of slope, which you'll have a lot. The slope is the rate of change, or how much something increases or changes. You're going to be quizzed on rate of change, but now you know it means how much just something increases or changing. $4,000 is the slope. Maybe you remember this rise over run business, from the last time you took math. Slope is your salary increase over how long it took to get the increase. And you'll see this a lot in my notes, y2 minus y1 over x2 minus x1. I use this a lot, and I would suggest that you use this little formula right here for slope, rise over run. Rise is the amount you go up, increase. So what rise is the y variable. That the y variable goes up and down. Run, the slope, is the denominator is run, how long it took you to get the increase, or how many years you were a nurse. And the run, that means the horizontal variable, is the x. So slope is the change in y over the change in x. So I took two random variables on our graph. One was when you made 81 grand, and that was in your third year. And then one was when you made 73 grand, and that was in your first year. And notice this is Y2, 81,000, and that means the salary, Y2. And the X2 was when you made that. That was the time, that was your third year. I took another random y variable from the graph or the table, and it was the y variable was 73 grand, and then the x variable was one year. Let me show you that on the table. This makes so much more sense in person, but we can scroll up to the table. There it is. Oops. Where's the table filled in? There it is. So when I did that equation, look, I took that randomly. I took that 81,000 and that 3, and then I took the 73,000 in the 1. And I'm going to use these in calculating the slope. I could have taken any random variable. Look, I could have taken the 93,000 and the 6 years, and then I could have taken the 77,000 and the 2 years. And in my handouts, I've got this explained in a lot more detail. Well, let's go down here to slope calculation. If I subtract these two, I get $8,000, and I subtract these, and I get 2. Now, this makes sense because in 2 years, this is years in our word problem, you get a $8,000 raise, or $4,000 raise per year. So hopefully that makes sense. And then I've got some other stuff down here. Nope, that's it. So this right here, this equation, you're going to be testing on a lot in your quizzes. Hopefully this word problem makes sense, and then make sure to look at all my handouts for further explanations of this. I'll make a part 2 video lecture on all the problems in my handout. Hey, good luck this week, and let me know if you have any questions, and enjoy your holiday.